Okay. Okay, let's go. So, welcome everybody. This is a kickoff meeting of the effort we are trying to move forward on the specification of the special identifier, which code name is SWHID, the SWHID identifier. A little bit of an outline of what we are going to do today. So the objective is to bring you all up to speed on the SWHID identification specification effort and kickstart the work. By the way, Moran just added in the chat the link to a note-taking document. It would be nice if you can complete with your name, address, affiliation, and maybe if you want a phrase or two on why you are interested in this effort. The organization we are planning today is to use 1 hour. Basically, we'll try to stick to half an hour, 45 minutes of presentation, leave the rest of the time for question and answer. Please do write the question in the chat. Moran will take them and organize the answer section. This is recorded, so if you don't want to appear, just turn off your camera. Your Zoom ID, if possible, if you can put it to set it to your full name, it will be helpful for us to follow up. And now, what is the structure of the presentation of today? First of all, a little bit of a background on what is an identifier. I think where everybody thinks, I mean, even I thought I knew what an identifier is, but actually I think it's a little bit more complicated. So let's start by setting the stage there, then focusing on the SWHID effort in particular. Then we will review together the way this spatial identifier, the SWHID identifier, are actually structured and how we compute them. Then we will focus on the key part of the specification, because we already have a draft that actually needs work, give you a little bit of a guided tour of how the contribution goes, or how the editorial process is actually set up, some information on the governance and licenses, basically everything that is needed to actually start the real work. So let's move in. First step, a little bit of a background on identifiers. Okay. First of all, it's important to distinguish two different things. So one typically thinks, let me move this thing here. What is identification? The goal of identifying an object is to have some kind of code or identifier that allows me to find out what an object is. So a typical example, let's take a case of a book. We have the ISBN number, which is, there is one number for every published book. It is specified in a standard, in ISO 2108, etc. And actually, if you look at the books you have, I mean, this is a picture of 3 books I have in my personal library. You see, each book comes with this number that is able to identify the product we are interested in. Then you have a different question, which is not identification, but location. So imagine you have one copy of a book. So this book object has an identifier, but then you have one copy of this book, which is in a particular library. And now if the idea is to find a particular copy of the book, you need to know where it is located. Okay, so actually, there are many copies of a book. There can be many different locations. Actually, locations can change. There are many approaches of identifying locations, and they are called numbers in libraries. And well, in our digital world, sometimes people actually do conflate identification with location. Okay, a URL, the Uniform Resource Locator, we all use on the internet, is for locating a web page. It's not an identifier of the web page. Okay? But here we actually are more focused on identification, not in location. Okay, so we want to identify software products, not find out where they are or where they are distributed. And then when you are focusing on identification, there are basically 2 main approaches for having system of identifiers. We use in our group to distinguish them with 2 terminologies. One are extrinsic identifiers and other are intrinsic identifier. The difference between an extrinsic and an intrinsic identifier is how the relation is created and maintained between the object that we want to identify and the identifier. There are traditionally 2 main approaches that were there much earlier than the internet. One is to organize a kind of a sequence of numbers and then a registry where you keep the relation between the identifier and the object. Think, for example, about your passport number or your social security number. If you only have the number, you don't have the registry, I mean, there is no relations between this number and yourself. And the other is to agree on some kind of standard way of computing the identifier from the object itself. So let me make it a little bit more concrete. And then, of course, the key desirable property in system identifier is to have them persistent. You want to be sure that in 1 year, 2 years, 10 years, if you have this identifier, you know what the object, designated object actually is. What it is, not where it is located. Remember, we are identifying now. So if we want to compare extrinsic and intrinsic, basically the relation between the object and the identifier in an extrinsic system identifier is in a register. You have some kind of authority maintaining a register, and actually persistence, I mean the maintaining, being sure that what is in a register is correct, is a property which is external to the technology that you use. It's basically a function of administrative care. For people who are familiar with this, if you look at the RFC 3650 that define the handle system, which is actually the mother of all identifiers like DOI, ARC, etc., which are very popular in libraries, it is written precisely like that. On the other side, if you look at intrinsic identifier, the relation is established by a convention. We agree on how we compute the identifier from the object. And then persistence is automatic, because if you agree on the convention, we compute the identifier the same way on the same object, we get the same result. So before the internet, example of extrinsic identifier, we have the passport number, the social security number, the ISBN book example we have seen. An intrinsic identifier were typically the notations that you find for chemistry, for music. So when you see NaCl, you know, this sodium chlorure, this is stable, something you do not need any registry to know what this is. It's just a convention on how you name chemical components. In the internet era, we have, again, extrinsic and intrinsic identifiers. So the extrinsic, you have a typical example in science or libraries are digital object identifier, handles, arcs, and many others. But for intrinsic identifiers, of course, we all use cryptographic hashes for tons of things. I mean, Git is based on hashes, Bitcoin based on hashes, and oh surprise, SWHIDs are based on hashes too. So here, we are interested in going through a process to provide a precise specification for an intrinsic identifier, which is a SWHID, to get towards making it a formalized norm, okay, a standard. So this is a general framework, right? Just to focus precisely on what we are working on. Now let's move to this SWHID identifier. So how is it structured? If you look at how it is actually designed and structured today, you will see that basically you have, this is a schema of a core SWHID identifier. You have a prefix, SWH, which is at the origin, the sort of heritage identifier. We'll come back to the name in a little bit. Then a schema version, because of course this schema may evolve over time. Then a tag, let's say what we are interested in actually identifying, and then a hash, this intrinsic object identifier here. What are the type of objects we can identify? Typically, they come from software. Okay, software is structured in a file system typically. So you have a file content. So this is a content tag when you identify a particular file content. Then a directory, but can also be identification of a particular revision or commit, identification of a release, identification of a snapshot, which is a full status of a repository at a given moment in time. And this is a core part of the SWHID identifier that can be computed entirely from the digital object you have in front of you. And then you have some optional parts, which are context information. So there are some contextual information you can add in form of key value pairs that can be used to tell where you actually found, this is a location, it's not only identification, where you found a particular object. What was the status of the full repository when you actually get a copy of it? What is the name of the file in its path, starting from the root directory associated particular revision that is identified? And you may also say, actually, I'm interested in this particular digital object here, but only in a particular fragment, the line 64 to 72. So this is the overall architecture of the identifier. We have been providing SWHIDs in the SWHID archive for 8 years. There are more than 30 billion such identifiers already there. It is today mentioned in the software package data exchange standard from the Linux Foundation, starting for version 2.2, but it is just a copy-paste of a part of the original old specification. We want to move to a real standard that can be mentioned. The prefix is registered with IANA. There is a Wikidata property that corresponds to some of these identifiers. So this is a starting point. Now the question is, how do we compute? I mean, this is structure, okay, but how do you compute this kind of identifiers? Let's go through a worked example. And by the way, a beautiful sequence of pictures that Nicola, who is online here, drafted many years ago. So this is a, let's say, conceptual representation of how a software digital artifact corresponding, for example, to a development repository can be seen as a graph, right? It is a directed acyclic graph. So these round things here, the file contents, then you have directory that contains some specific contents. Directories can be contained in other directories. Then at some moments you decided to make a revision or a commit here, but commits are chained one to the other, the development and the merges, the forks, etc., etc. Then you have releases that are designated revision. Then may have the list of all the evolution of branches in a particular repository. And this is a very simplified version of what a typical version control system can hold. Now, how do we compute the identifier here? The first step is very, very easy. So imagine you have a particular file content, okay? It's a sequence of bytes that is the content of a particular file. On this sequence of bytes, it is very easy to compute a particular hash, actually compute many. In the SWHID archive, you will find many hashes, SHA-1, SHA-266, SHA-1-GIT, etc., etc. Very, very easy. And you have command lines that can compute the hash for you, pretty easy. Now, if you want to move, so once you have this hash represents precisely, because they are cryptographic hashes, represent precisely one particular content in a software artifact. Now, if you want to move up, we need to choose one of these kind of hashes, and in the SWHID identifier, the decision has been made to stick to the one which is used in Git, which is the most popular one. It is the SHA-1-GIT. Once you have this, now the big question, sorry, I'm moving backwards. The big question is, how should I handle the higher object? Because, I mean, computing hash of content easy. I have a command, I run it. But for a directory, so imagine you have a directory on your machine. Okay, typically a directory, as you see in your interface, is a bunch of files, a bunch of subdirectories with names, some properties, some are read-only, some are executable, etc. How can we compute the hash of a directory? Well, the idea is kind of easy. So basically, for each of the file or directories which are in your particular directory, you create one line. I mean, this is concept. Textual line that contains name, the name of the file, the hash of that file that you already computed, okay, because this is smaller, so you compute it already. A tag that says it is a file or it is something else, and some information on the rights on that file, executable, not executable, etc. And if it is a directory, well, you suppose you know already how to compute the hash of a directory, you put here the hash of a directory with the name. But if you create this thing, this is just a text file. It is a textual representation of a directory. So once you have a text file, you can again compute a hash on it. And then you get the hash of this particular directory. And then with this hash, you have a full representation of all the subgraphs that correspond to the directory. But wait, it is not that easy, because the way you represent the file name, the order in which you put these lines in the textual representation is extremely important to make sure you get all the same hash at the end. Okay, so this needs to be specified very, very precisely. Well, once you know this trick, it's easy to see how you handle the other things, revision, release, snapshot. It's the same thing. You get a textual representation of that particular object. So for example, when you revision, this is what you typically see in a version control system interface or on code hosting platform. And then what you want is get a standardized textual representation with all the information, typically a pointer to the status of the code, the previous commit, the author, the committer, the test, etc. This is a standardized representation, compute a hash here again. And the same, at this point, you have a hash that identifies this full subtree. And then again, the same game goes for releases, and the same game goes for snapshots, which is just a sequence of all the hashes of all the head tags of all the branches in the repository. So this is a way this is built. And actually, we did not invent this. I mean, this is a basic way that the Git version control system works. The only point is that the identifier we are proposing here are standardized. They do not depend on a specific version control system. Can be computed for everything. Okay. So now that we have seen how the identifier are built, I mean, again, it's a bird's eye view. It is not a very precise specification. How can we move to a publicly available specification, which is our job here, which is a step number 1 to get the full standard at the end? Well, first things first, maybe a few seconds on the name of the game, okay? At the origin, you heard me say software heritage identifier. It's a kind of a Pavlovian reflex. We have been using it so much time that it's difficult for me to change. But at the origin, that was an acronym that was bound to the initiative we are carrying on in Software Heritage to archive all the software source code in the world. Okay, so the acronym was basically SW for software, H for heritage, and ID for identifier. But now that we are moving to a much broader constituency, maybe we should reformulate it, because these identifiers based on a cryptographic hash can be used independently of the software heritage archive, can be computed independently of software heritage archive. They are not restricted to source code. Basically, everything digital that can be in a file system can be hashed and identified exactly the same way. So the proposal, if we all agree, would be to stop using the term software heritage identifier and use the term software hash identifier, and we keep the same acronym, okay, SWHID. This is just for the name of the game. We'll get back to this a little bit later on. But then, next step, our goal now is to create a specification. What is a specification? It's a document that provides a complete, precise, non-ambiguous description of all the components of this identifier system. So the picture you have seen, again, thanks a lot, Nicolas, for drawing this many years ago, they're beautiful for understanding, to give you the concept, but they are very, very simplified representation. The reality is a little bit different when you go down to the details, okay? So you want a real, complete, precise, non-ambiguous specification. How you build these lines, how you order these lines, how you compute exactly the hash there. Because the goal of a standard or a full specification is to allow any person which is skilled in the art to implement, to get an implementation of this standard and get exactly the same result. Okay. So if we want to get there, there are many, many things we need to get right in the specification. For example, the 5 key parts in the core identifier, the content identifier, the directory identifier, release identifier, revision identifier, snapshot identifier, This nice picture you have seen now need to be very precise specification, and somebody that never heard about the identifier looking at the specification should be able to say, okay, I know how to implement it. Also, the qualifiers need to be specified. These are kind of easier, but they're also very important. And of course, we need to get right the reference to the external standard that are used. At some moment, we use algorithm. I mean, we use SHA-1 or SHA-1-GIT or whatever. What kind of algorithm are we using to compute the hashes? This must be very, very precise. And so we do not start from nothing, okay? Of course, there have been years of development implementation. There is a high-level documentation from the software heritage team. By the way, in these slides that are already online will be shared. Everything in blue is a link to the corresponding supporting documents, so you can click here. So we have this high-level documentation. We have two complete independent implementation. One implementation in Python, which is the one that has been developed by Software Heritage team, and one in OCaml, which is a different programming language developed by the team, actually by Andreas Quiz Online, by the team who maintains the Objective Camel package manager open. And then we have a draft specification that the core team has produced for you to start the work that contains many, many, many elements and needs now to be completed. And these are the starting point. Now, how does this work? First of all, a little bit about governance and licenses here. There is a governance document. Actually, if you click on the link here, I hope this work should pop up. You have this governance document here that defines the governance of the process, etc. And basically, the key points that the decision making is consensus based. Remember, consensus doesn't mean unanimity. Consensus is a global consensus thing. There can be dissenting opinions. And then we have an open process to produce what we will call an approved specification. At some moment, the specification gets to a point where we say, okay, this approved specification version 1. Okay. Then the license, of course, the goal is to have a very open specification. So there is a specific community specification license that you can get by clicking here. And we expect all contributors to accept to make their contribution available through this community specification license. So you have a specific contributor license agreement, which is accepted by just signing off your contribution on GitHub. The process, you will see this in a few minutes. The process is based on GitHub. And you have a core team, which is helping with the coordination. So the core team is composed by Alexios Transfer from Intel, Jean-François Grammatique, who is emeritus at INRIA, Moran Gompeter, and myself from Software Heritage, Stefano Zacchiroli, who is both on Software Heritage and on Institut Telecom. I hope I don't make mistakes. Stefano is Institut Telecom, I hope, no? I mean, the official term. And then we have split for the moment this core team in two groups. I mean, one are the maintainers, people that push you to work and try to edit the document, make sure it really works well. And then editors that will make the final reading to make sure everything is coherent, etc. And this is to start up. Of course, if there are volunteers to join, maintainers and editors, please get in contact with us and we'll see what can be done. Now for the DIGADs set apart, now how we work. Well, basically, the workflow is based on GitHub for the moment. So the sources of the specification are on a specific repository, which is SWHID/specification here. You can join, you can look, it is open. You can connect to it and see what is going on, etc. very easily. You have a bunch of actions, GitHub actions which are set up. So every time a contribution is merged to this, the source code of the specification here, you have the SWHID.org website, which is automatically updated with a rendered version of the current status of the specification. So it's pretty easy to use. The contribution workflow is based on the typical process on GitHub. So issues and pull requests. We will see a couple of examples in a few minutes. Of course, pull request must be signed off. That is to say, your contribution to the standard must accept to work on this community license specification. Then the people who are named editors, actually in reality, this is mistaken. Maintainers merge pull request on consensus. When we assess there is a consensus, we merge the pull request, and every time we merge, I mean the current status of the specification is revealed. We also have a mailing list. You have seen we shared the information on the mailing list from most of you. We think it will mostly be used for coordination. Okay, so if there is need for having a virtual meeting, we schedule it. If we need to call for a vote, we do it. If we need to announce a version freeze and asking people to review in a given moment, we do this on this mailing list. Now, you see even here, contribution workflow. If you click on the blue link, you get on the information on the contributing workflow, how you work, the initials and pull requests, how you should submit some changes, how it works with the sign off, etc., etc. We will not go through these details. So this is just a high level view. And now, let's have a very small guided tour. So the idea is we want to work with issues and pull requests. I know some of you are already pretty familiar with what happens using GitHub, but please bear with us a few minutes if you review these kind of things. A typical example, you will have some issues. Let's see one of them. You see, this issue here was, okay, we need to precisely specify how the core is identifier for a directory node, this tag there. So here I opened an issue some time ago. So you see in the document there is a fragment which was not formal at all, needed to be specified. So the issue is open. Then you have a conversation going on in the issue. So I try to pull the leg to Andrea saying, hey, you did an implementation, maybe you can help. And he answered, here is a relevant piece of code that you can look at. Then Alexio said, it's not very clear because how do you describe this and that? These details are important, so there are some discussion. And then we had a virtual meeting with Leo and Nicola, etc., that led to creating a pull request that proposes a real, precise description on which we can keep up the conversation. So now there is a pull request, you go on the pull request, you see there is a concrete proposal that you find here. The file has been changed. Here are the changes. To actually get a precise version of specification. And on this particular pull request, we can have a discussion here. Okay, it can be a conversation. See how this works. Okay, so basically this is the way we are supposed to work. And if you look at all the issues that are open, these issues are tagged with different tags. Come on, GitHub. Okay, tagged with different tags. Some are documentation, some are questions, some are blockers, etc. So we try to curate a little bit these issues by saying main blockers are really things that need to get done before we can even think of having a decent specification. Then there are other things like, for example, proposal for enhancements, either to identifier, to the documentation, etc., etc. So this is a typical thing. And for example, we can every now and then we can take a vote. For example, for changing the acronym from software heritage identifier to software hash identifier. Here is a poll. So I have this link here that we can share later, and we can take a vote between the people participating in this particular effort. You see, you can go here, put your name, your email, and then say, yes, I prefer to keep a software identifier. No, it's okay to have software hash identifier. Or no, none of the ways okay. Then that's a way of taking a vote, for example. So what is the road ahead? The idea, we would like to be as efficient as possible, still with priority to completeness, accuracy, right? So the idea would be to have version 1 out as soon as possible. Let me dream out loud here. End of April would be fantastic, because this first version will help us establish the whole process. In this initial phase, we should only cover what is already known and being used. So not focus on extension changes, it only define precisely what is being used. So we did an effort to go through the issues and mark as blocker the ones which are needed to complete this phase 1. And so in this initial phase, we should focus essentially on these items that are double blocker and make sure they are complete, precise, and unambiguous. And here it will be very precious to have the point of view of somebody which is not directly using or developing the specification to help us understand what is open, the pull requests which are already open for each of these blocker elements are precise, complete, etc. And it is important to have, of course, the people who actually did write some implementation to check that the technical details are correct. And then phase 2 would be towards the version 1.1, where we could handle all the other suggestion, input, feedback that can come out, hopefully with the idea to get to a version candidate that will be presented to the ISO organization to become a standard for the fast start process, which is typically for publicly available specification, and that will be carried on thanks to the help of the Linux Foundation. So I think I kept my promise to be more or less half an hour, not much more. So the main entry point are the main website of the SWHID, which is .org. Maybe we can start calling software hash identifier, and then the sources of the specification. So I think this is the end of what we wanted to show to you today. And now we can start. If you have any question, we can take that. Okay, so.
Thank you, Roberto. I think that I see 2 questions here on the chat.
I can make use of the silence and ask the questions directly if you're okay with that. First of all, well, this is Julian Kocha with ScanOSS.
Yes, go ahead.
The question is, when I saw the hashing, calculating a hash of a directory, which is a hash of the hashes of the files and directories inside, I wonder if there is value in hashing the file names. What is the actual value? Actually, I'm wondering what is the value of hashing the file names, because if you don't do that, then you just hash the hashes, then you have tolerance to changes. Again, my use case is always identification of open source, and this is, the higher the chances of identifying, and that is the reason why I'm asking. You're muted, Roberto.
Can you hear me now?
Yes, perfectly.
Okay, fantastic. So thanks for asking this question, Julian. Just to be precise here, I understand your use case, and it is pretty legitimate, of course, etc. Here, the fact of hashing the file name is really to make sure we identify the very same exact software artifacts. Let me give you an example. Okay, if you download the file system, you download the project, this project will have file names. You run a binary or an executable computed out of that. This can read the files or read the elements of test cases or directory which are there. So if you do not provide the file name, you do not know what you are doing. Okay, you even have a make file in there that to build the project, you need to compile this and that and that. What is it? In the make file, you have the file names. You need to keep the file names. And so if you have 2 sets of files which have the same identical content but different file names, they are not the same project. Okay, they will not produce the same result.
Totally understand. Totally understand. Thanks for the clarification. And while I'm talking, if I can have another question that I have not managed to write, is this a presentation available somewhere? And if so, could the link be shared?
Yeah,
I'm particularly
sure.
interested.
The presentation is already online. I will share it right away. It is on the SWHID annex.
Okay, okay, great.
Already shared it. And this presentation will be recorded. This discussion will be recorded, made available too. I mean, the idea of this process is to be open. All right, this process is completely.
I'd be interested in casting the vote for the naming, which my humble opinion is that there's a lot of, I've seen SWHID in many presentations already from many companies, so I don't think it will be wise to dilute by having a new name. That will be my
it's not a new name. You get SWHID as it is. The only point is that if you ask what is the significance, how do you spell out the acronym, instead of saying software heritage ID, you say software hash ID. That's just
okay, good.
You keep the same identical acronym. We don't touch the acronym at all. That would be crazy.
Good. Thank you.
So, can I ask about the hashing method?
Yes.
Is there you have a directed acyclic graph, so is there always a unique way of navigating to a final artifact, or could there be more than one pathway through the directed acyclic graph, in which case you would end up with different identifiers for the same artifact?
Well, if you follow the way, I mean, just to be very clear, if you look at there is one precondition for using this identifier is that the graph you're looking at is direct and acyclic. If there are cycles in the graph, you cannot do it. I mean, there are other ways of computing hashing for cyclic structure, but this is out of the scope of this particular work. But if you look at the way it is designed, you go from the leaves towards the root. And so even if there are many different paths of going from the root to a particular file content, the way you compute the hash stays the same. So you should play it in a picture. I don't know how to write a picture here, but actually there are no ambiguity. You compute it exactly the same way if you specify precisely the way you represent the intermediate nodes. Because this is a local operation, so there are no issues even if there are many different paths in there.
Roberto, it's Kate.
Hi, Kate.
Hi.
Good morning. Good early morning. I'm very sorry for the.
It's okay. The hash of the hashes is something that we've been sort of working with in SPDX for a long time. And there were problems certainly around the character returns in certain character sets. Have you guys been considering that in inclusion of the names?
Yeah, indeed. And it's a very complicated thing. Actually, we're thinking through this a lot. I mean, and the point is that we want to make sure that in the way you compute the hash, you start from the artifact you have at hand. So if the file name in the spec, you will see the pull request. I mean, the file name is considered just a sequence of bytes. So exactly the thing that the file system gives you when you try to compute the hashes. I know this is maybe in corner cases, it can be a source of some headaches and nightmares because depending on the file system where you are, the file names are not the same. But if the file names are not the same, the artifact is not the same. Okay, so imagine you run a make file with the name of files, the representation is not the right one. Then you will have a problem nonetheless. I mean, so the problem is not the identifier, the problem is what you're doing with your file system. So for the moment, the way the SWHID identifier work, they actually faithfully reflect what you see on your file system when you do the calculation.
Okay.
Then you can think of other things. So you can think of how could I find out a standard that allows me to actually find, you see, this is related to the question by Julian before. There may be use cases where you want to actually see the two things that have different intrinsic identifier actually are the same. Okay, but we are building the foundation for this, making sure you know exactly what is a binary object you are representing here and there, And then you can build an extra layer to see, to say, hey, actually, this is the same as the other one.
Okay.
Alexios? Alexios?
Yeah, thanks. Following up to that, because Kate, I spent a lot of time discussing with Roberto about this stuff. So the way that we should think about it is like the example that Roberto showed in the beginning, like ISBN, right? It doesn't mean that if you have an ISBN for a book, this is the only ISBN, right? Because the same book, you know, Tolstoy's Anna Karenina, can have more than one ISBNs because of the different editions.
The edition.
Yes. So it's the same as, you know, you can have a software hash ID. Well, have to get used to that. You can have a software hash ID for the same software if it's on a system that has EBSDIC file names instead of ASCII and stuff like that, right? So.
Thanks a lot, Alexios, for this clarification. Actually, the idea of making the analogy with the edition of the book is brilliant. I mean, it's very clear. And I see a question by Yes about the evolution of the hash. Yes, you see, I mean, this is version 1 of the identifier. The idea is we are trying to make a very precise specification of the version 1 of the identifier, which is the one that has been around for quite a while and that is now used in many, many different places. But this is version 1, and since the beginning, and this was a key contribution by Stefan, I mean, this version number means, yes, there will be a version 2, and maybe a version 3, depending on the evolution you will see either in the hashing algorithm or on the standard you want to use. But these prefixes are there just to make sure you will be able to have different versions of the identifiers in the future. But for version 1, the hashing algorithm is cast in stone. Well, cast in stone. There is one open issue. You will see one of the blocker issues is to decide exactly what version of the hash we'll be using, because now we have the Git, SHA-1 Git thing, but you remember there were these conflicts between, I mean, these people in Google spent a huge amount of money to build the conflict on SHA-1 at a given moment in time. So now most Git libraries use a particular trick to detect whether the recognition can be happening using this trick by Google. And in that case, they produce some different results. So there is some discussion to have there. So do we stick to the original old SHA-1 Git algorithm, or do we move to the more recent, let's say, armored, protected, anti-collision protected Git hash? So there is a little bit of discussion there.
Okay, thanks you. Thanks.
Yeah, you're welcome. And Julian, yes, sure. We all know that we are living in difficult time. I mean, quantum computing and maybe AI, the times are reckoned in algorithm, etc. So the idea is to get this specification out because it is already used. And then another thing that not necessarily everybody knows, but when you go through the ISO process, then you need to regularly update the specification or drop the specification. So it's a process there in the standardization at ISO. So once you get standard for something, every 5 years, you need to update it, or even less if there is a need. So of course, this is a living object. We need to create the first specification, get the first version of the standard out, and then we will keep working, following what is going on. On our side, but this is just our side on software editors, okay? So we will maintain all the current identifier in the archive. And if need be, a new version 2 of the identifier will come up, we will maintain the 2. This is our commitment.
Thank you, Roberto.
Okay. Any other questions?
I see another question in the chat by Daniel about the current limitation to be addressed in future version, and how do you expect the community to contribute?
Sorry, I didn't hear.
The second part is, how do you expect the community to contribute?
Okay.
The first part was about the limitations, but I think that you have answered this part, and the other one was about the contribution.
Well, so let me spell it again. So here we have a rather broad community around the table. If you see, you have people coming from research, people coming from open science, people coming from industry, people coming from developing community, different kind of areas, which is pretty normal, and it is very welcome to have this broad constituency, because this kind of tool we are building, this identifier, can be used in many, many, many different use cases. So let me spell it out again. So the kind of contribution we are waiting, not just me, I was forgetting. Here I'm talking because I'm the only one free today to do this work, but you have the whole core team behind this. So Moran and Stefano and Alexios and Jean-Francois and me, so we are already 5. We are trying to lead this work. So what we expect from all of you is, depending on your background and your level of technical understanding, is in this first phase 1, go through the open issues which are market blocker, in particular the pull requests which are already available that give the precise specification of how we compute this internal node. Read them and say if you understand clearly. Is it clear enough? There are things which are not clear. Right? And if you already worked on the implementation of one thing, go through these kind of things and check whether this seems correct with respect to the implementation you already made. I mean, these are the key points you really need to get right in phase 1 to get the first release of the spec, which will not be the final one, but I mean, at least we have common ground. So you see, depending who you are, I mean, the community is very broad. And then in phase 2, we will be interested in getting potentially more use cases, more suggestions. There is already one open there. Right? For example, we have qualifiers to identify line numbers, but if forget for a moment about source code and think of this as something that can be used for any kind of software, even including binaries, then maybe another qualifier could be a byte offset. I mean, say bytes from 1,233 to 4,305 instead of lines. Okay, this is an extension compared to what we have already, but we would like to leave this as phase 2. Okay, so phase 1, make sure what is written there is precise for everybody. And phase 2, add new use cases. So I hope this, Daniel, gives an answer on what we are expecting from the community.
Yes, thank you very much.
There's a question from a bit before. Yeah.
Okay.
A bit before from Juanio. So the question is, does it make sense to add other PIDs into the SWHID context qualifiers?
For example?
So example here has, if the software project has a DOI, it could be interesting to add this DOI to the SWHID of every repository for this software project. That's the example in the question.
This, I do not know if it makes sense. I mean, we are a community, we are working together, we need to discuss all this, but I propose this kind of extension to have them in phase 2. Doesn't prevent you from opening up the issue right away. You can do it right away. But then I would focus the first time of our effort on phase 1 on getting rid of the current blocker. And yes, this is typically the kind of things we are expecting from the community. So having people that have different use cases come up with ideas where something else can be needed, since we are building this specification for everybody, not just for assets or heritage. So it will be very welcome. Doesn't mean it will go in. It depends on the discussion and what we do as a community. And so I see another question by Rob. I don't know if because I'm just looking at the last slides. I don't know what happened in the previous one. So if you see something else, just tell me.
I think that's the last question in the chat for now. So yes, go. Should I read it out loud for the video? is an extension to datasets on the radar. My use case is numerical analysis to support public policy development, a mix of code base and database, therefore.
Yes, indeed. I mean, this is a very, very reasonable question. And actually, if you look at the technology and if you look at the way data sets are structured, and these are digital objects like the other ones, so then it would be perfect sense to use this kind of identifiers also for data set. But wait a second, I mean, this kind of intrinsic identifier makes sense when your digital object has a very precisely identifiable canonical representation. So for example, if you try to use this kind of identifier to identify papers, which can be in PDF, PDF-A, PostScript, etc., they all produce the same thing on the screen, but they are digitally very, very different. I mean, the hash is not very useful. So data set, well, it depends on the kind of data set you have. If you have a canonical representation of data set, having a hash representation is fantastic. Is this particular specification here useful for data set? That's kind of a question mark, I would say. Maybe for data sets, the hash you want to use is different from the one we are using here for our software. Not. But again, phase 2, this is or maybe phase 2, I would say, this is a pretty interesting discussion. Okay. So
I don't see any other questions on the chat, but we have 5 minutes to go. So
yeah, so maybe what we can say, Moran, again, Alexios, Stefano, Jean-François will be here, and actually already Alexios, Stefano contributed a lot, and Jean-François, we discussed a lot about the governance, etc., to make sure we are following community standards and all this. And thanks for the Linux Foundation, Kate. Thanks a lot to you for helping getting the support of Linux Foundation in this process. So we try to do this, but now it's really a community effort. So the point is that Moran and me, as much as we can, we will try to pull your legs. I mean, so we regularly go through the discussions on the issues, on the pull request, if needed, ask for other people to contribute more. If we think there is more discussion to be had on a particular issue or a pull request, we will do it. And then we will try to merge when we find a consensus. So it's up to us to pull your legs, but please don't disappear. I mean, it's very important that you as a community do contribute to all this and go through this and test the interface and these pull requests and issues, etc. Go and what you see. And the idea is really to try in a reasonably small amount of time to have a version 1 out there. And starting with the cast your vote for the change of explanation of the acronym. So not really change of name. The name will be always SWHID. And now the explanation of the acronym could be sort of hash identifier. Let's see if you like it. It's a way of contributing starting from now, immediately. Another question here, do we have recurrent meetings? Not necessarily. I think the discussion through the workflow on GitHub should be the most effective way of doing things. Maybe we will trigger meetings at a given moment in time, particularly when we think the specification is stable. Maybe we will trigger a meeting there. And now we have 4 minutes left. Let me start by saying thanks a lot for joining this effort. We know everybody here around the table has a lot of things to do, but we really believe this is a key contribution to a common need. So let's try to move it forward and have this specification out as soon as possible. Okay. Bob, you have another question, or is it an old hand?
Yeah, it's a new hand. It's a bit provocative. Why isn't the word blockchain used in this discussion?
The point is we do not, in the identifiers, Yeah, you are right. I mean, we are kind of, I do not use the word blockchain here because typically when you say blockchain to people, they immediately think about Bitcoins or this kind of thing. And so in a blockchain, you have basically two things. I mean, the Merkle have computation. I mean, a blockchain is linear, so it's much easier than what we do here with a graph. And the distributed consensus algorithm. And so since we are not speaking about any distributed consensus algorithm in transactions, using the term blockchain, I think would be a way of getting the conversation completely off track. So we tried not to say it, I don't know. Even if some pieces of technology are the same, of course. Okay, time to go. So thanks a lot. Do not hesitate if you have questions, get in touch specifically with Moran and me. We will send on the discussion. By the way, if there are people in this meeting that are not already on the SWHID discussion mailing list, please write to me or Moran to add you to the mailing list. And then we will share the link to the recording, the link to the presentation in this phase of the discussion. Okay. So should I stop the recording? Yes, I will stop the recording here.